Hi dear students, welcome to Geeta's classes. In this class, we are going to see inverse Laplace transform of integrals. So we know that L of f of t, if the Laplace transform of the function f of t is f bar of s, then L inverse of f bar of s is equal to f of t. Please remember, whenever you have f of t, it is L inverse of f bar of s. If you have f bar of s, it is L of f of t. And please try to remember, study all these formulas, and all the proofs are available in my previous classes. Okay. And Laplace transform of all these functions are important. If you are thorough with these things, then only we can easily understand or find out the inverse Laplace transform. And these are all some standards, inverse Laplace transform of some standard functions. So try to remember these formulas. So if you are thorough with these things, you can do very easily. Inverse Laplace transform will be very, very easy. Okay. So this is the inverse Laplace transform of integral. So if L inverse of f bar of s is f of t, then integral L inverse of integral s to infinity f bar of s ds is equal to f of t by t. We know that already in Laplace transform we have studied this, right? If the if multiplication is there, t into f of t means differentiation. F of t divided by t means integration. Please remember. So L of f of t by t is equal to, we know that it is integral s to infinity f bar of s ds. Actually, without this t, you find the Laplace transform of the remaining function and integrate from s to infinity. So from this, you get L inverse of integral s to infinity f bar of s ds is equal to f of t by t. So we are going to find out the inverse Laplace transform of some functions using this theorem. Okay. So when to use this integrals, Laplace transform of integrals, in the denominator you have the whole power 2. Okay. Some function, the whole power 2. Then it will be easy when you integrate. So how we are going to do this? Let f bar of, always remember, whenever you want to find out inverse Laplace transform of this sum function, that function you assume it as f bar of s. So let f bar of s is equal to 1 by s plus 1 the whole square. Right? Now, because you have the whole power something, whole power 2 in the denominator, then it will be, you have to integrate. So integral s to infinity f bar of s ds is equal to integral s to infinity 1 by s plus 1 the whole square into ds. So which is equal to, we can write it as integral s to infinity s plus 1 the whole power minus 2, right, into ds. That is equal to s plus 1 the whole power minus 2 plus 1 divided by minus 2 plus 1. You have to apply the limits from s to infinity. That is equal to, that is integral s to infinity f bar of s ds is equal to s plus 1 the whole power minus 1, s plus 1 the whole power minus 1 divided by minus 1 from s to infinity. That I am going to write it as minus, I will take it outside. So 1 by s plus 1, right, from s to infinity. When you substitute infinity, what will you get? 0. 1 by, yes, 1 by infinity, so it will be 0, right? So this is equal to minus of 0 for upper limit infinity, minus s is replaced by s only, so 1 by s plus 1, the same function you will be getting. That is 1 by s plus 1. What is this? Integral s to infinity f bar of s ds is 1 by s plus 1. Now let us find out L inverse of integral s to infinity f bar of s ds, which is equal to L inverse of 1 by s plus 1, taking inverse Laplace transform on both sides. So in the left hand side, what is this? By the theorem. By the theorem, L inverse of integral s to infinity f bar of s ds is equal to f of t by t. So let us replace that. Okay. So this is f of t by t is equal to L inverse of 1 by s plus 1 is e power minus t, using the standard function. Always remember, we have taken the given function as f bar of s. You are asked to find out L inverse of f bar of s. So L inverse of f bar of s is always f of t. This is what we are going to find out, f of t. Okay. So now f of t we want. So f of t is equal to t into e power minus t. Bring this t to the right hand side. So t into e power minus t is the answer. So always remember, take the given function as f bar of s, then integrating, then applying the formula and bringing it to the right hand side. So f of t is our required function. Okay. So here, always remember f bar of s is equal to s plus 2 by whatever function is given, you take it as assume that function as f bar of s. Because you have the whole squared in the denominator, it is easy if you use integral function. So integrate s to infinity, f bar of s ds is equal to integral s to infinity s plus 2 divided by s squared plus 4s plus 5 the whole squared into ds, right? So here in the denominator, if you have the differential of the denominator in the numerator, then we can easily do f of t into f dash of t formula. Okay. So here s squared plus 4s plus 5. If you differentiate, what will you get? 2s plus 4. So here we have s plus 2. So I am going to multiply and divide it by 2. So this will become 1 by 2 into integral s to infinity s squared plus 4s plus 5 the whole power minus 2 into differentiation of this is 2s plus 4 into ds. So I can write it as 1 by 2 into minus 1 by minus s squared plus 4s plus 5 the whole power minus 2 plus 1 divided by minus 2 plus 1. So that minus I am taking it outside, and s squared plus 4s plus 5 the whole power minus 1. So I can write it as 1 by s squared plus 4s plus 5 the whole power 1 from s to infinity. The minus I am taking it outside. So minus 1 by 2 into, when you apply infinity it will become 0. 1 by infinity, that is 0, minus when you replace s by s, the same function. So 1 by s squared plus 4s plus 5. Right? So minus minus it will be, when you take minus inside, it will become plus. So 1 by 2 into 1 by s squared plus 4s plus 5. Right? What is this? Integral s to infinity f bar of s ds. F bar of s ds is equal to plus 1 by 2. 1 by 2 into 1 by s squared plus 4s plus 5. So let us take inverse Laplace transform on both sides. So L inverse of integral s to infinity f bar of s ds is equal to 1 by 2 into L inverse of 1 by s squared plus 4s plus 5. Right? This is equal to 1 by 2 into. How will you do this? You have to bring it to the s plus a form. Right? So 1 by, I have here 4s, that is 2 into 2. I have explained this in detail in the previous classes. Please go through that if you have any doubts. So 2 into 2. So I want 2 here. 2 squared here. 2 squared is, so I am going to split this 5 as 4 plus 1. So s squared plus 4s plus 4 plus 1. L inverse of. So this is equal to 1 by 2 into L inverse of 1 by s plus 2 the whole squared plus 1. So this can be written as 1 by 2 into e power minus 2t, first shifting theorem, into L inverse of 1 by s squared plus 1. That is e power minus 2t by 2 into, what is L inverse of 1 by s squared plus 1? It is sin t. And what is there in the left hand side? L inverse of integral s to infinity f bar of s ds is, by the theorem we know that this is f of t by t. What do you need? F of t, right? F L inverse of f bar of s we require, that is f of t. We want f of t. So f of t is equal to, bring this t to the right hand side. So t into e power minus 2t divided by 2 into sin t. Okay, this is the answer. T into e power minus 2t by 2 into sin t. Next question, find L inverse of s by s squared minus a squared the whole squared. If you don't understand any step in this, please post it in the comment box so that I'll clear your doubts. Okay. So find L inverse of s by s squared minus a squared the whole squared. Always, what did I say? F bar of s is equal to, take the given function as f bar of s by s squared minus a squared the whole squared. Right? So integral, because you have in the denominator you have the whole squared. Okay. So integral will be easier if you do take integration, then it will be easier for finding the inverse Laplace transform. So integral s to infinity f bar of s ds is integral s to infinity s by s squared minus a squared the whole squared into ds. Right? That is integral s to infinity. Now you have, if you have 2 in the numerator, we can apply easily. So 1 by 2 into, directly I'll write 1 by 2 into 1 by s squared minus 1 by s squared minus a squared from s to infinity. So this is equal to minus 1 by 2 into 0 minus of 1 by s squared minus a squared, applying the upper limit and lower limit. So this is equal to minus and minus, it will become plus. So 1 by 2 into 1 by s squared minus a squared. Right? So what is there in the left hand side? Integral s to infinity f bar of s ds. So let us take L inverse on both sides. So integral s to infinity f bar of s ds is equal to 1 by 2 into L inverse of 1 by s squared minus a squared. So I want a here. If you want to use the formula, I want a here. So multiply and divide by a, 1 by a. Therefore, in the left hand side, what is this? L inverse of integral s to infinity f bar of s ds by theorem. It is f of t by t in the left hand side. And in the right hand side, already we have 1 by 2a into L inverse of a by s squared minus a squared is sin h a t. Therefore, what is our requirement? It is f of t. Okay, L inverse of f bar of s is f of t. So, t by 2a into sin h a t is the answer. Similarly, if you have s squared plus a squared the whole squared, you can try with the same procedure. The answer is, this is equal to L inverse of, answer is 1 by 2a into, here you have a squared minus a squared, therefore we had sin h a t. If it is plus, then it is sin a t. Same procedure you can follow. You will be getting 1 by a 2a sin a t. Okay. And one more question. It is a different question. Here it is integral is there of course, but you have to evaluate this. L inverse of integral s to infinity is already there. So let us take here log of u minus 1 by u plus 1 du, and you have to replace it by s. So we can take it as a function of s. Okay. So log of u minus 1, whatever we are doing for s, you can apply for u also. So let us take f bar of u as log of u minus 1 by u plus 1. Whenever you have the functions log, tan inverse or cot inverse, what you have to do? Do you remember? You have to differentiate. So d by du of, so this can be written as f bar of u is equal to, first let me expand it. So log of u minus 1 minus log of u plus 1. So if you differentiate on both sides, differentiating with respect to u, on both sides we get f dash of u is equal to 1 by u minus 1 minus 1 by u plus 1. Right? So L inverse of f dash of u is equal to L inverse of 1 by u minus 1. In the place of s, I am using u, that's all. So 1 by u plus 1. So what is this L inverse of f dash of u minus 1 into t into f of u? L inverse of f of u. Okay. Actually L inverse of f bar of s, so L inverse of f of u you can take, f bar of u. No, this is actually L inverse of f bar of u only. Into that is L inverse of here you can differentiate, split them using linearity property. So L inverse of 1 by u plus 1. So what is this? E power t minus e power minus t. Here you have minus t into L inverse of f bar of u is f of t. So minus t into f of t is e power minus t, e power t minus e power minus t. Therefore, f of t is equal to I am taking this t to the right hand side and minus also to the right hand side. Therefore, I can write it as e power minus t minus e power t divided by t. The left hand side you have t into f of t. I am bringing the t and minus also to the right hand side. So, I am writing e power minus t first and e power t next. Okay. What is it f of t the required function? No. Here actually f bar of u I have taken only log of u minus 1 by u plus 1. Only this much I have taken it as f bar of u. So we have found out inverse Laplace transform of log of u minus 1 by u plus 1 only. If you take the entire function as f bar of s, I want f of t only, okay. But integral s to infinity. Therefore, when now you take L inverse of, therefore L inverse of integral s to infinity f bar of u du is equal to, we know that f bar, L inverse of f bar of u du, you know, and if it is s to infinity, you know that this is f of t by t, right? Therefore, which is f of t is already we know that this is e power minus t by e power minus e power t divided by t. Already we have one more t here, therefore it is t squared. So L inverse of, what is f bar of u? We have taken f bar of u as log of, right? Therefore L inverse of integral s to infinity log of u minus 1 by u plus 1 into du is equal to e power minus t by minus e power t by t squared. Understood? Here without integral I have taken this function as f bar of u. I have found out the inverse Laplace transform of that function, and for that function we know again if you take integral then f of t, the answer divided by L inverse of, without this integral whatever is there divided by t. So without this integral L inverse of f that function we have found out it to be e power minus t by minus e power t by t. So you have one more t is there, so that you bring it to the right hand side. So it is t squared. Already we have one t and multiply by t. Okay. So with this integration of all these functions are over, and next is convolution product and convolution theorem is also there. Then last topic is solving the differential equation, ordinary differential equation using Laplace transform. Okay. So please give a like to this class and share it with your friends also, so that it will be useful for them. Thank you so much for listening.